In this video, we're going to maximize the area of something called a Norman window that has a perimeter of 40 feet. So a Norman window is when there's a semicircle on top of a rectangle. And what we know is that this diameter of the semicircle is also the same as this dimension of the rectangle. Now we don't know the dimension of this rectangle, so we got to label our unknowns. So we'll call this D for diameter. And maybe we call this side H for the height of the window, which makes this side also D and this side also H. Now first off, we want to maximize area, so let's just come up with a formula for the area. Well, we got the rectangle underneath and we got a half a circle. So the area of the half circle is 1/2 for half of the circle. And the area of a circle is pi times the radius squared, and the radius is right there, it's D over 2. It's only half the diameter. So D over 2 squared. Now we're going to add on the area of that rectangle, which is D times H. Now, we have a constraint, and that's that the perimeter can only be 40 feet. The perimeter is the distance around. So we have H plus D plus H plus half of the circumference of the circle. So circumference is pi times the diameter, but we only want half of that. So right there is the perimeter. We'll clean that up a bit here in a second, and we know that that has to be 40. So let's simplify both what we got, our function and our constraint. So D over 2 squared is D squared over 4, and then we got times a half there. So this is going to become pi over 8 times D squared plus D times H. Now, our equation for perimeter, we have a couple of h's in there, so we have 2h and plus d plus pi over 2d equals 40. Now, this is probably going to be easier to solve for h and then plug in here. So let's do that, and when we do that, we're going to solve for h and divide. So we're going to subtract these off of 40 and divide them by 2. So divide everything by 2, that's going to give us 20 minus d over 2 minus pi over 4d. What we're going to do is we're going to plug that h in to this h. So we get pi over 8 d squared plus d times 20 minus d over 2 minus pi over 4d. And let's go ahead and rewrite that down here. I'm going to distribute that d through. So I have pi over 8 d squared out front. Now distributing the d through, I'll have 20d minus d squared over 2 minus pi over 4 d squared. Alright, let's go ahead and finish this off. We're going to take the derivative, call it a prime. So dropping the 2 down, so we have 2 pi over 8 or pi over 4d plus 20. Drop the 2 down, you'll have 2d over 2 or just a negative d. Again, drop the 2 down, you'll have 2 pi over 4 or just a negative pi over 2d. And we set this to 0. Now doing so, I'm going to leave the 20 on the left-hand side and move everything else over to the right. So I'm going to have a positive pi over 2d plus d plus, minus this guy here, pi over 4d. So I can factor a d out on that side. So 20 is equal to d times pi over 2 plus 1 minus pi over 4. I'm not worried about calculating that right now. I'll do it at the end. So d is going to be 20 over pi over 2 plus 1 minus pi over 4, which we could simplify. But because we want a number for this, let's just go ahead and calculate that. So calculating our d, we have 20 divided by pi over 2 plus 1 minus pi over 4. So our d is about 11.2 feet. Since we started the whole thing in feet, our units will be in feet. Now from here, we can give the maximum area or find the diameter. This asks us to maximize the area. Now remember, we've got the function for area right here, and I've got my value for d right here. So I'm just going to plug that in to what I have right here. So the max area is going to be approximately, and I'll show you how we can do that real nice and slick using the answer key. The answer key, just so you know, is right here above the negative symbol. What I'm going to do is, now watch this line here, and instead of putting in d, I'm going to put in answer. So I'm going to put in pi divided by 8, and that pulls up my last answer, squared, plus 20 times my answer, minus my answer squared divided by 2, minus pi divided by 4 times my answer squared. And I get the max area is about 112.02 square feet.